In this problem, we have a half-life for the first order reaction. And remember here that again the half-life is defined as t 1/2 is equal to natural log of 2 over k. And we know it's 60 minutes. This means that every 60 minutes, half of the material remains. This is 2 half-lives, so it's going to result in a reaction where half of it reacts after 60 minutes and another half of it reacts in the other 60 minutes for a total of 1/4. Okay. Here, 240 minutes is 4 half-lives. So half of a half of a half of a half is 1/16. Okay. 600 minutes is 10 half-lives. So that's 1/2 times 1/2 times 1/2 times, 10 times. And it might be easier to just do that on your calculator, or we could just express it as this answer here. Now 89 minutes is not a perfect multiple of the half-life. To solve this problem, we need to use the integrated rate equation. All right. And we'll have to plug in some things to calculate some percentages. Over here, though, let's go ahead and calculate what the k is equal to. K is equal to the natural log of 2 divided by the half-life of 60 minutes. And that comes out to be, when I do this on my calculator, 0.0116 reciprocal minutes. So that's what we'll plug in here. The time is 89 minutes. And the initial amount, we just can say 100%. Okay. And we subtract whatever we're solving for final. Okay. So let's do some math here. Multiply both sides by -1. And we'll go ahead and solve for this. So on the right we have negative. And 89 minutes is our time period. And we want to add the natural log of the initial amount, and I'll use 100%. Let's see what we get on the right-hand side. I get 3.57. And I want to use the inverse log button on my calculator. Shift LN is what I do. And what I get for the amount at time t, right, 89 minutes later, is 35.6%. Okay, 36% if I round off to 2 sig figs. Now I've noticed that this problem here wants percentages, so coming back up, let's switch to blue. You can do 1 divided by 4 times 100 on your calculator, and that's 25%. Okay, 1/16 is times 100 is 6.25%. Okay, and let's go ahead and try to figure out how to do this problem here. 1/2 times itself 10 times I've got a button there on my calculator, but I don't have it. So I just punch it all in. That's equal to 9.77 times 10 to the minus 4, multiply by 100, right, to convert that to a percent, and we have 0.098% or 977%. Okay, so that's how you do this problem. If the time is an exact multiple of the half-life, you just half of a half, however many times you need to do that. If it's not a perfect multiple, you have to use this integrated rate equation.